Today's lesson is 3-7, day 1. We're going to solve absolute value inequalities. Our objective for today, again, is to solve absolute value inequalities and graph their solutions on a number line. Okay. It says that there are going to be 7, hold on just a second. It says there's going to be 7 examples. We're going to split this into 2 days, and we're only going to do 3 of them today. Okay. So it says think about it. You're not writing any of this down. Absolute value refers to the distance from 0. We've talked a little bit about absolute value before and about how it cannot be negative because we're talking about distance. So it says if the absolute value of x equals 4, that means that x is exactly 4 units from 0. If I'm looking at the number line, that means that 4 units from 0, if I go to the left 4 units, I end up at -4. And if I go to the right 4 units, I end up at +4. So my answers for x are -4 and +4. Because the absolute value of -4 is 4, and the absolute value of +4 is also 4. Now if we change this and we say the absolute value of x is less than 4, that means that x is less than 4 units from 0. So if we look at this number line again, we go out to the left -4 units and to the right -4 units. And this time, there are open circles because -4 and +4 are not included. So it says less than 4 units. That means it could be 1 unit away from 0, 2 units away from 0, 3 units away from 0, to either the right or the left. So we notice that if it's less than, here we have a less than symbol. You can see our little play on words here. Less than means that this is going to turn into a and compound inequality. Now we're going to change it and say the absolute value of x is greater than 4. What this means is that I'm more than 4 units from 0. So if I look to the left and I go more than 4 units from 0, that could be -5, -6, -7, and so on. That would be more than 4 units from the 0 point. I can also go to the right, and if I go to the right 5 units, that's greater than 4 units from 0. If I go to the 6, that's greater than 4 units from 0. So if you notice, again, our play on words here, if it's a greater sign, it's a great or, which means that this is going to turn into an or compound inequality. Once we split it up and figure out whether it's an and or an or, it's going to look exactly like what we did yesterday and the day before with compound inequalities. Also notice down here it says x is less than -4 or x is greater than +4. So right here it looks exactly the way it looks up here without the absolute value bars. Over here, I've flipped the inequality and I've changed my 4 to a negative. And that's basically what we're going to be doing with these inequalities today, is to get them set up to look like what we did yesterday. It says write this information down and go ahead and write it down. I know that you have some of the and or set notation and that kind of thing, but this reminds you again that less than is going to be an and statement and great or is going to be an or statement. So take a minute and pause the video and make sure that you have everything in blue written down. All right, go ahead and take a minute and write down number 1.
Okay, so we're going to look at these on paper today. So for number 1, again, across the top of your paper, you should have lesson 3-7, day 1. And number 1 is the absolute value of x plus 5 is less than 2. So because this is a less than problem, again, my play on words, less than, I know that this is going to be an and compound inequality. So I'm going to set up my problem. My absolute value bars are by themselves, so just like I have been on all of my other absolute value problems, I'm going to say x plus 5. Over here, I'm going to say x plus 5, okay? Now, my less than sign and my 2. You know in the old school inequality, or I'm sorry, the old school absolute value problems that we taught you to do, you changed your number on the other side of the problem from positive to negative. So right here I have a positive 2, so this is no different. It's going to become a negative 2. Now the difference here is that I do have to flip my sign, okay? So not only am I making this number from positive to negative, but now I'm having to flip my sign in the middle. Now over here, I'm just going to bring down my sign and my number. Nothing changes, okay? So over here, you should have x plus 5 is greater than negative 2. And over here, you should have x plus 5 is less than 2. Now, just like all the other absolute value inequalities, or all the other absolute value problems I have solved, I'm going to subtract 5 on both sides. And you can do that 2 at once, or you can do 1 at a time. Negative 2 minus 5 gives me negative 7. Bring down my x, bring down my inequality sign. These 5 minus 5 cancels, and then I have 2 minus 5, which gives me negative 3, and I'm going to bring down my inequality sign. Now, your and set notation is going to be the squigglies x such that, and again, I want you to write this, blank is less than x is less than blank. Okay? That's your set notation. No matter what your answer is, your set notation for an and problem is always going to look like that. Blank is less than x is less than blank. Now you can simply fill in your negative 7 and your negative 3. My numbers are listed least to greatest, just like they ought to be, because I set my problem up in the right order. I put my negatives on this side and my positive on this side. So now I'm going to graph this. I have solved it and set it, and now I'm going to graph it. I have negative 7. Oh, sorry, there is no 0 in the middle there. That should be negative 5, negative 4. Okay? Because both my numbers are negative, and I was thinking one was positive and one was negative. Alright, so negative 7 and negative 2. I'm sorry, negative 3. So I've gone one number above and one number below. One number above my highest number, one number below my lowest number, and then I filled in the numbers in between. I look at my inequality sign. I should have an open circle because there is no extra mark. And now I'm going to shade because it is an and problem. My x is in the middle, and I'm going to shade in the middle. Again, the and problems are always shaded in the middle, and if you're not sure, look, your x is in the middle, you're shading in the middle. So we have solved, we have set, we have graphed, and now we can check. We're going to check with a number that is inside the shaded region. So I'm going to go with a number negative 5 because it's in the middle of my shaded region. I have to come back to the original problem to check. I always come back to the original problem to check. So I'm going to say the absolute value of x plus 5 is less than 2. This is my check. Alright, I'm checking again with a negative 5. So I have negative 5 plus 5 is less than 2. Negative 5 plus 5 gives me 0. The absolute value of 0 is 0 because it can't be positive or negative. And 0 is less than 2. That checks. So make sure that you have your solve, set, graph, and check written down before you move on. This is all for problem number 1. Alright, go ahead and get down problem number 2. The absolute value of 3x is greater than 9. So the first thing I'm going to do is look at my sign in the middle, and I see that it is a greater sign. So I'm going to write my little play on words, great or, over here. I know that this is going to be an or problem because there is a greater sign there. So I'm going to set up my two inequalities. My absolute value bars are by themselves, so I'm going to say 3x here and 3x here. So I'm dropping the bars. Here, I'm making my positive 9 into a negative 9. And I'm taking this sign and I'm flipping it around. Here, I'm bringing down my problem just like it is. I'm just dropping the bars. So here I just made my positive 9 into a negative 9 and I flipped the sign. And here I just kept it the same. I just dropped my inequality bars. So now I know that when a letter and a number are touching, they're being multiplied, and I have to undo that multiplication. So I'm going to divide by 3. These 3's cancel, and that gives me x is less than negative 9 divided by 3 gives me negative 3. I'm going to divide both sides here by 3. That gives me x is greater than 3. So now I have x is less than negative 3, or x is greater than 3. So I have to set, and I'm going to say x such that x is less than blank, or x is greater than blank. This is my or set notation. X is less than blank or x is greater than blank. My numbers from least to greatest, negative 3 to positive 3. And now I have solved and set. My next step is to graph.
Sorry, I just wanted to...
All right, so now we're going to graph. And on my number line, I know that I'm going to go one number below negative 3. And one number above positive 3. Because I have no extra mark, I have an open circle at my negative 3 and an open circle at my positive 3. Now is when I need to slow down and look at my problem and say, okay, this is an or problem, not an and problem. So in an or problem, I'm shading to the outside. And if I'm not sure, I can look at my inequality signs, and they look like little arrows. This arrow is pointing this way, and this arrow is pointing that way. So if I've done my set notation properly, I can look at that and see the arrows and know I'm shading to the outside. So I've solved, I've set, I've graphed, and now I have to check. I have to come back to the original problem to check with, which is the absolute value of 3x is greater than 9. Now I'm going to check. I have to check with two separate numbers. Okay, so I have to check twice because I have two separate shaded regions, and I'm going to check one number in one shaded region and then another number in another shaded region. So I'm going to check with negative 4 and positive 4. So I'm going to write my problem out twice because I'm going to check two times. The absolute value of 3 times negative 4 is greater than 9. The absolute value of 3 times positive 4 is greater than 9. 3 times negative 4 gives me negative 12. The absolute value of negative 12 is positive 12, and 12 is greater than 9. 3 times positive 4 gives me 12. The absolute value of positive 12 is 12, and that is greater than 9. So that checks and that checks. So I know that I did my problem correctly. Make sure that you have all of the work for the solve, set, the graph, and the check all written down before you move on. All right, go ahead and write down problem number 3. The absolute value of x plus 1 is less than or equal to 5. Just when you thought you were getting the hang of this and you knew exactly where we were going, we throw a wrench in your plans here. Now, if you look at this problem, you notice that it's a little bit different from 1 and 2 in that the absolute value bars are not isolated. They're not by themselves on this side of the problem. They've got this plus 1 over here with them. So just like the original absolute value problems we worked, you have to get the bars by themselves before you can move forward. So the first thing that we've got to do is move our positive 1 to the other side, and we do that by subtracting 1. So that gives us the absolute value of x. This cancels, is less than or equal to, and 5 minus 1 is 4. Now, all I have to do, check out my sign. I see that this is a less than problem. And I have to set up two separate equations. I'm going to drop my bars and I'm going to say, or two separate inequalities, sorry. I'm going to drop my bars, flip my sign, make my 4 a negative. Drop my bars, keep my sign the same, leave my 4 a positive. And my solving is already done for me here. So that's as far as I have to take this one. So now I've solved. I'm going to put it in my set notation. Again, your and set notation is x such that blank is less than or equal to x is less than or equal to blank. I'm going to fill in my blanks from from least to greatest, -4 to +4. I've solved, I have set, now I have to graph. I'm going to go one below -4 and one above +4. 3, 2, 1, 0, -1, -2. I'm out of space. -3. Sorry. All right. I look at my inequality sign. I see an extra mark, so I'm going to make it dark. I have a closed circle at the -4 and a closed circle at the +4. Obviously, my number line is not drawn to scale, and I'm sorry, I ran out of space. I'm sure that'll never happen to you. It's an and my x is in the middle, so I'm going to shade in the middle. And I have in my shaded region every number from -4 to +4, so I can pick any of those numbers to check with. For this problem, I'm going to go ahead and check with, we'll say -2. So I come back to my original problem, which is absolute value of x plus 1 is less than or equal to 5. The -2, again, is in my shaded region, so I'm going to say the absolute value of -2 plus 1 is less than or equal to 5. The absolute value of -2 is +2. 2 plus 1 gives me 3. 3 is less than or equal to 5. So that checks out. Make sure that you have all of that work, the solve, the set, the graph, and the check written down. And this is the last problem on your video for today. We will do 4 through 6 tomorrow. Thank you for watching.